Assalamu alaikum for everyone. First, I would like to express my thanks and appreciation to the conference staff in ISDA 2020 for accepting my paper, Analysis and Simulation for Mobile Ad Hoc Network using QualNet Simulator. I am presenter Muhammad Salah Aboud. This paper ID 89 from 12 to 15 December. So in this slide for introduction, I will talk about the QualNet. The first version of QualNet was launched in 2000 and still developed till 2015 because it has many advantages for that. Network simulation designed and assessed network algorithms and protocols in multiple network-to-network environment. Therefore, simulation can generally be defined as a technique used to implement a network on a computer with the help of some mathematical calculation. So, a sensor network is typically a wireless ad hoc network. So each sensor supports a multi-hop routing algorithm and transmitting nodes, transferring a packet to a database station. Immediate neighbors and then across the network. Routers thus develop an understanding of the network topology. So on this slide, the IODV, DSR and OLSR wireless sensor network comparison findings using a QualNet simulator in CBR. We have 5 CBR like this. So we used CBR traffic are illustrated in this study as shown in figure 1. So in our study aims to make use of QualNet simulators to compare the performance of the IODV, DSR and OLSR routing protocols of packet delivery ratio and average end-to-end. In table 1, the main components of QualNet and the advantage of its use will be clarified in addition to the challenges, and finally we use the key features of QualNet. These features that enable the creation of a virtual network environment to get rid of these challenges illustrated in table 1. A simulation was used, then analyzed and validated in addition to flexibility and easy of implementation, thus obtaining actual result before deploying the sensor and computers in the real world. In this table 2, we will show the most important simulators, similarities and differences between the following simulators: QualNet, NS3, NS2, OMNet, OPNet, and so on. So, what distinguishes QualNet from other? It's good for GUI and good for large networks and fast simulation result. In this slide, we will explain the simulation procedure of QualNet like in this figure 2. So we will present the schematic diagram of the QualNet portion. The simulation comprises 4 main steps, like these steps. The first step was employed to build the MANET environment, analyzes the performance of a scalable network. In this step, illustrate the characteristics of MANET, like network size, network type, node number, traffic, application time, and so on. In the second step, IODV, DSR, and OLSR have been used. While in this step, or the third step, the simulation scenario has been done with several parameters to test and assess performance in PDR, and end-to-end delay in 5 CBR lines of 15 nodes. And in table 3 we will see just the main parameters for QualNet simulation. And finally, results in the visualization graphical model are included to view the result of total packets and total packets received and the packet delivery ratio when the value is 1024. In this slide, we will see two figures for packet delivery ratio, one for send and the second figure for received. So in figure 3, the total packet sent for AOGV, DSR, for each AOGV, DSR and OLSR are 1050 or 1950, and I represented this result in Microsoft Excel. So in figure 4, the total packets received for AOGV is 1938, but for DSR I get 1946, and for OLSR I get 1791. So the best protocol in packet received is DSR, and I represented this result also in Microsoft Excel to get this graph. So we will note that the DSR value is biggest or bigger than the other two protocols. So the best protocol in our article is DSR because it has the biggest value in both total packet received and the packet delivery ratio, as in figure 4 and figure 5. This slide we will show the average end-to-end delay for this figure. So for the 3 AOGV, DSR and the OLSR protocol, we showed the AOGV protocol is the smallest value relative to others. The AOGV protocol is the smallest value relative to others, so it is the best protocol in our case, and that depends on the CBR line. We used 5 CBR line that arrive between the nodes, and we are represented this result as shown in Microsoft Excel. In this slide, we will analyze and discussion of our result. The total packet sent for AOGV, DSR, and OLSR protocols are the same value for the figure 3. The total packet were received in figure 4 show that DSR performed better than AOGV and OLSR. In packet delivery ratio, in this case, we are using the equation and got on different value between the 3 protocol, and the best value was DSR protocol because it was the highest value than AOGV and OLSR. The average end-to-end delay, AOGV performed better than DSR and OLSR as shown in figure 6. OLSR has the highest delay while AODV has the lowest delay. Finally, all those results depend on the CBR line that arrived between the nodes. The last slide is conclusion. Through the aforementioned result in using the tree protocol AODV, DSR and OLSR by using QualNet simulation, we have obtained some important conclusions among the most important ones, as in the following: end-to-end delay is the lowest for AODV but the highest for OLSR. Least error obtained in the received signals of AODV and maximum DSR. OLSR has the lowest queue length. The largest number of packets is received in DSR and the minimum is the OLSR. DSR performed better than AODV and OLSR in total packets received. AODV better than DSR and OLSR in end-to-end delay. Thank you for listening and also apologize if there were any mistakes during the presentation, as I did not practice giving a conference by recording. Thank you again. I'm presenter Muhammad Salah, paper ID 89. Thank you. Goodbye.